To Chapter 1, Section 3. Today we're going to take a little bit of a turn away from solving equations to looking at modeling quantities. And the key concept here that we're going to focus on is this idea of unit analysis. And now this is going to come back to help you later on in your high school career when you're in chemistry class and you need to convert between different units of measurement. All right, so here's our example. We're going to convert 4.8 gallons to fluid ounces. In other words, how many fluid ounces are there in 4.8 gallons of a liquid? Well, we know that there are 16 cups per gallon and that there are 8 fluid ounces per cup. Keep in mind the word per is going to represent division or a fraction. So we can set these two units up as a fraction. We're going to start off with 4.8 gallons, and 4.8 can be written as a fraction as 4.8 over 1. We're going to multiply that to 16 cups per 1 gallon, and then we're going to multiply that result to 8 fluid ounces per cup. Now, when we do this, we're going to end up with the gallons, the units of gallons, dividing each other out, and our units of cups dividing each other out. And we're going to be left with just the units of fluid ounces. So keep in mind when we multiply fractions, we're going to multiply the numerators times each other and the denominators times each other. So that's 1 times 1 times 1 across our denominators, which is just 1. And then 4.8 times 16 times 8. And that's going to result in 614.4, and the unit that we're left with is fluid ounces. So in 4.8 gallons, there are 614.4 fluid ounces. All right, in example 1, we're going to take a little bit of a shift here, and we're going to look at proportional relationships. Proportional relationships can help us find lengths of similar triangles. So below it says to use the diagram to find the height of the tree if your height is 6 foot and your shadow length is 8 feet. So if we take a look here at the picture, we got the person here is 6 foot. Their shadow on the ground is 8 foot. And between the person and their shadow and the ray of light that comes down to the ground, that forms this blue right triangle. Well, a similar triangle is formed by the height of the tree, which we are going to try to find, the length of its shadow, and a parallel beam of light that comes down from the sun and forms that shadow. So these are similar triangles. In other words, their sides will be proportional to each other. So if we take the corresponding side lengths of the 6 foot of the person over the height of the tree, that's the variable here that we're going to look to find, and set it equal to the length of its shadow, which is 8 feet here for the person, over 30 feet here for the tree, then what we have is a proportional relationship. All right, so we can solve this by cross multiplying. 8 times h is 8h, 6 times 30 is 180, and now we're going to divide both sides by 8, and that gives us the height of the tree to be 22.5 feet. So again, we have two ratios that equal to each other. That's a proportion. A proportional relationship can be solved by doing this process of cross multiplication. In example 2, we see that there's a table that shows some statistics for a basketball player's performance. We want to use rates. Rates, remember, are units or quantities of different units. All right, to compare the performance of game 1 to the performance of game 2. So here's the first rate we're going to take a look at, the quantity of points per shot. So in game 1, we're going to identify their number of points and divide it by the number of shots. Here's game 1, we got points 37, shots 47. So we have 37 over 47 compared to game 2, and I'm just going to write 2 down here. And our points were 26 over 26. Now, if we go ahead and reduce those or simplify those fractions, then we'll have about 0.78 in game 1 points per shot. And then here, in game 2, we have 1 point per shot. So if we're going to compare these two, we're looking at reducing those fractions down and keeping the units on them. And we can say that game number 2, he scored more points per shot. Let's do the same thing with rebounds per minute. So in game number 1 here, our rebounds were 11 per minutes played was 42. So that's 11 over 42. And then game number 2, we had 5 rebounds over 40 minutes. So pause the video now and go ahead and take a second to compare those 2 rebounds per minute. All right, let's move on to example 3. In example 3, we are given that there are 2,000 pounds in 1 ton, 16 ounces in 1 pound. Now we're going to use this unit analysis strategy to convert 1.2 tons to ounces. So we're going to start off with 1.2 tons, and we are going to multiply that by the ratio of 2,000 pounds per 1 ton. Finally, we're going to multiply that by the ratio of 16 ounces per 1 pound. Now you can see as we multiply straight across, numerators times the numerators, we're going to have 1.2 times 2,000 times 16. And then on the bottom, we're going to have 1 times 1 times 1, which is just 1. What's going to happen to our units? Well, tons are going to divide by tons. Pounds are going to divide by pounds. And I'm going to be left with an answer that's just in ounces. So this will give me the number of ounces in 1.2 tons. When we do that multiplication of 1.2 times 2,000 times 16, we're going to end up with 38,400 ounces. All right, let's take a look at example 4. We got a wind turbine that casts a shadow that extends 22 meters long. At the same time of day, a senior who stands 2.1 meters tall notices that his shadow is 0.8 meters. How tall is that wind turbine? All right, so we're going to draw our little wind turbine here. And it's a very simplified drawing of that, but it's got a shadow that's cast along the ground here that's 22 meters long. And we're going to find the height of that wind turbine. And at the same time, we got a senior. Here's their senior, a little graduation cap. Ooh. And they're standing 2.1 meters tall and cast a shadow that's 0.8 meters long. All right, so we have a ray of sunshine that comes down and forms this right triangle with the wind turbine, and a parallel beam of light that comes down and forms that shadow with the senior. So these are 2 similar triangles, and we're simply going to set up a proportion. So we have the height of the senior over the height of the wind turbine, and we're going to set that equal to the length of the shadow over the length of the wind turbine shadow. All right, so here we have our 2.1. We're going to now solve this by cross multiplying. 2.1 times 22 is equal to 0.8 times x. And that is going to set up the equation. 0.8x is equal to 46.2. And then when we divide over that 0.8, we'll get x, which is the height of our wind turbine, to be 57.75 meters. All right, guys, this last example here for today, you're going to be asked to find out which city has the greater average rainfall, and you're going to need to convert these so that they have comparable units. Pause the video and give example 5 a try on your own. We'll talk about it when we come back to class tomorrow.